Hello everyone, my name is LLaMA-3 and in this video I'm going to walk you through how to fine-tune LLaMA-3 for psychology question answering. Now don't worry if you're not familiar with fine-tuning. I'll be explaining each step of the process in detail, and by the end of this tutorial you'll be able to apply this to any model and dataset for your own project. But before I start explaining the code, let's take a moment to talk about what fine-tuning actually is and why we need it. If you've used models like GPT-4 or LLaMA-3, you probably know they're amazing at understanding and generating a human-like language on pretty much anything. Sometimes it feels like they know everything, right? But here's the thing, these models are trained on massive general datasets, and while they're great at handling broad topics, they often struggle when it comes to specialized knowledge. For example, if you ask one of these models questions about a very niche topic or information that they've never been exposed to, they might give you an answer that sounds right at first, but when you dig deeper, you realize it's not accurate, something we call hallucination. That's where fine-tuning comes in play. Fine-tuning is like giving a general-purpose model a specialized education. Instead of doing everything from scratch, we adapt a pre-trained model so it can become an expert in a specific area. We simply provide it with targeted data, let it learn from those examples, and boom, it becomes much better at answering specialized questions. Now that we've covered the basics, let's jump into the actual tutorial. I've created a Google Colab notebook to help you fine-tune LLaMA-3. It has all the steps you need. If you're not familiar with Google Colab, it's a cloud-based platform where you can run Python code and use GPUs for free. You can even upgrade to a faster GPU, but the free T4 GPU is perfect for our needs right now. First thing first, we need to set up our environment. We'll be installing a few essential libraries that will make fine-tuning 10 times easier. Once these are installed, we're good to go. Let's load the model. Here, we'll be using Unsloth, which is a framework designed to simplify and optimize the process of working with large language models. We'll be loading LLaMA-3 8B 4-bit. This is a smaller, lighter version of the LLaMA-3 model. You can of course pick any other model to work with. Notice the load in 4-bit equals true flag. This enables 4-bit quantization for the model during loading, which reduces memory usage while maintaining a strong performance, making it more efficient for our resource-limited setup. Okay, now this is where it gets really interesting. We're going to use LoRA, a technique commonly used for fine-tuning large language models. It lets us adapt only a small set of parameters for our specific task. Essentially, we're tweaking just a few layers instead of retraining the entire model. This is especially useful when we're working with models that have a large number of parameters. We're setting things like LoRA alpha to control how strongly we adapt the parameters, and LoRA dropout to avoid overfitting. Let's run this cell and move to the dataset. Since we're fine-tuning for a psychology question answering task, we need a dataset that includes psychology questions and their answers. Fortunately, we have access to pre-built datasets on Hugging Face. I chose this dataset, Psychology Question Answer by Bolt Monkey, but you can find other interesting ones or even create your own. Just make sure they are in the same format we need. Fine-tuning is all about making sure our model gets the right data, so we need to format the data properly. We do this by creating a system prompt. By structuring the prompt clearly, we guide the model to understand its role and the task it's supposed to perform. The idea is simple. Each sample in the dataset should include a question, which goes in the input, and the corresponding answer, which goes in the output. This way, the input data aligns perfectly with the model's requirement, helping reduce inconsistencies during training. Once the dataset is loaded, we can move on to the training. First, let's configure the training parameters. This is where we define things like learning rate, batch size, number of steps, and how often we log training progress. We're going to use SFT Trainer from the TRL library, which simplifies the fine-tuning process. Here's how we set it up. We've set the batch size to 2, meaning we'll be processing 2 samples at a time, and max steps to 60 to keep things fast. But you can set number of training epochs equals 1 for a full run, and turn off max steps. Try to play around with these parameters and see what it does. Okay, it's time to train. This is where all the magic happens. We just have to call trainer.train, and the fine-tuning process starts. This will show up, and all we have to do is click on the link, sign up, and get your API key. You'll see the loss decrease over time. That means the model is getting better. And great, we successfully fine-tuned our model. It's time to test it. We're going to use it to answer some questions. Let's take some examples from the dataset. How about this one? The model.generate method generates a response based on our input. The result should be a response that answers the question based on the training data. And as you can see, it worked. The answer is correct. It's not an exact copy of the training answer, which is actually good because that means the model has learned and is able to generate original responses based on the pattern it was trained on. It even adapted to the answering style, short, concise, and to the point. And that's it. You've got yourself a fine-tuned model ready for use. All that is left to do is save it. This is a great starting point for creating specialized question answering systems for any domain. I hope you found this tutorial helpful. Feel free to leave questions or comments down below.